Welcome to Lesson 7-2. Today we're going to review synthetic division. We spent yesterday reviewing how to divide using area models, and I introduced you to some long division. Today we're going to go ahead and focus on our synthetic division. And synthetic division is basically like a shortcut to doing long division. All right, so just going through the little spiel here. It says this method here says can only be used when dividing by linear factors of the form x plus or minus a. So as we try to use this form of division, we can only divide by linear factors that are in that form. So for instance here, if I had something in the top here, right, and I was going to divide it by x plus 3, that would be totally fine. Okay, I could divide something by x minus 3. That's totally fine. I could divide by something like x plus 3/4. That would be fine. What I can't have is something like this. Let's say 2x plus 1, right? This one is not going to work. It is not in this form, x plus or minus a. So that's something that's important as we get started into this here. You'll notice that our divisors are all going to be in this form. Let's get started. So, synthetic division, a condensed version of long division without the variables. So this problem came from the homework. We have x to the third plus x squared minus 14x plus 2. And in order to do this, if you don't remember it, okay, first thing, right, we notice that this fits that form that we just talked about, x plus or minus a. Okay, so right now we have x minus 3, right? And this is a factor, right? When we see something like that, right? It could be like, oh, x minus 3 is equal to 0, right? But this is a factor of something, okay? Now, if we took it and we added the 3 to the other side, right? Now we know that 3 is a root, right? And that's important here because when you do synthetic division, we need to focus on this bottom factor, and I need to know kind of what that root would be. So since in this case here, if I set it equal to 0 and solved it and I got x is equal to 3, right, I'm going to end up using the root value. So if you forgot how to do it, here's a quick recap. So we're going to say, all right, well, I've got 3, and I'm going to put it up here in this little box, right? Remember, this is the root value, not the factor that goes up there. So it's always going to be like the opposite of what you kind of see right here. Okay, then we're going to take the coefficients of our expression. So our coefficients up here, right? This would be like a 1. This would be a 1. We have negative 14, and then we have a positive 2. So we're going to write those down. 1, 1, negative 14, and 2. Right, and just leave a little space so you can tell that that's not 11 or something like that instead. Leave a little space below as well. So we're going to, and then we'll put our equal bar at the bottom. So here's how it goes, right? We take our first term, which is 1, right? And we're just going to go straight down and rewrite that down underneath here. So we're going to write that down on the bottom. So that becomes a 1 down here. Next, we're going to find this value by doing our 1 times our 3 and then writing it in there. Okay, so 1 times 3 obviously is 3. So we've got a 3 right here. Then we're going to take it and we are going to add this column. So we're going to add these together. So 1 plus 3 gives us 4. And now we do the same process over. So we take 4 and we multiply it by 3. That's going to give us 12. And then that one gets written over in here. So we have 12 right here. We add them together again, right? Negative 14 plus 12 is going to be negative 2. And then we do it again. Negative 2 times our 3 is negative 6. And then when we take it and we add those together, we get negative 4. Now we're out of numbers. So if we end up with something at the end here, that would end up being our remainder. So this is our remainder right here. And then we just need to go backwards by degree, right? So if this is our remainder, this means this is a degree of 0. This would be a degree of 1, and this would be a degree of 2. So as we look at writing that out here, right? So degree of 2, we'd say this is going to be x squared plus 4x minus 2. And then we'll add our remainder over our divisor. So it'd be plus negative 4 over x minus 3. And you'll see that, if you look at your homework from last night, this matches that answer. All right, so we'll just work through a few practice ones here. So we have 5b to the third plus 13b squared minus 10b minus 12, and we're dividing it by b plus 3. So remember, this is our factor, so the root is going to be negative 3. That's what's going to go into the little box. All right, so then we're going to list out our coefficients in order. We've got 5, we've got 13, we've got negative 10, and we've got negative 12. Add in our equal bar, and away we go. Let's drop our 5. We've got 5 down here. 5 times negative 3 is negative 15. We add them together to get negative 2. Negative 2 times negative 3 is 6. Negative 10 plus 6 is going to be negative 4. And then negative 4 times negative 3 gives us positive 12. When we add those last two, we get 0, which means there is going to be no remainder. Okay, so that means that b plus 3 was a factor of that original expression. So we'll take it here. Remember, still going in order here. So this has 3 terms. So this would be a 5x squared minus 2x minus 4. Okay, so that's the answer to this. All right, moving on. This one, we have 3m to the 5th plus m minus 1, and it's being multiplied times m plus 1 to the negative 1st. Okay, so this one just has a couple things in there to make it look more complicated. Okay, so we're missing some degrees in this first polynomial, right? So we need to take it and think about filling those in. This would be like saying 3m to the 5th plus 0m to the 4th plus 0m to the 3rd plus 0m squared plus m, and then minus 1, right? And then remember, if we took this here and we made it a positive exponent, this would be like saying 1 over m plus 1 to like the positive first. So in the end, like if we multiply that together, that's going to look like this. So our root value is going to end up being negative 1. So we'll go ahead and throw that in here. There's our negative 1. And then we'll list out our coefficients. So we have 3, 0, 0, 0, 1, and negative 1. And then we'll do the same process. Bring down our 3. 3 times negative 1 is negative 3. 0 plus negative 3. Now we're going to multiply, get a positive 3. Multiply, get a negative 3. Get a positive 3, which gives us 4. 4 times negative 1 is negative 4. When we add those together, we get negative 5. Okay, so we have a remainder on this one. So remember again, our degree of 0, 1, 2, 3, and 4. So in this case, we're going to have a 3x to the 4th minus 3x to the 3rd plus 3x squared minus 3x plus 4. And then we'll add, and we'll put a negative 5 in the top. And, oops, I did it all as x's. They're supposed to be m's. So I'll fix those. Right, so we had, these were all supposed to be m's. Don't make that boo-boo like I did. And that is our answer. So once you have it down, right, you could go ahead and move on with it here, but then we run into ones like this, right? And hopefully you're already saying, oh, well, wait a minute here, right? This one is not that linear factor in that form. We have a coefficient on our x. So what we're going to need to do in this case is we need to somehow get rid of that coefficient. So one thing we can do, right, is if I want to get rid of that 2, I'm going to factor that 2 out. Okay, and say, well, if I factor out that 2, what would I have left over? Well, 2 times x would have been 2x, and then 2 times 1/2 gives us 1. So this would be 2 times the quantity of x plus 1/2. Well, what we do to the bottom, we also must do to the top. So we will take it and we will factor out a 2. Right, and so when I do that there, right now I have a 4x to the 4th. Now notice I don't have any degrees of 3, so that would be like having plus 0x to the 3rd. So when I factor out 2 from 0, it doesn't matter, so it'd still be a 0x to the 3rd. Factor out 2 from negative 4x squared to be minus 2x squared. And then we have 1x, so that would be a 1/2 x plus 2. And since we have this common factor now in the top and the bottom, right, this 2 and this 2, we can go ahead and cancel those out, right, because it should still be proportional. And that leaves us with a linear factor in the correct form here. So if x plus 1/2 is our factor, that means that the root would be negative 1/2. And then we'll put in our coefficients: 4, 0, negative 2, positive 1/2, and positive 2. And then we'll go through the same process. Bring down the 4. 4 times negative 1/2 is negative 2. We add those, we get negative 2. This would be 1, which gives us negative 1. Negative 1 times negative 1/2 is positive 1/2, which gets us a nice clean 1 right there. And then 1 times negative 1/2 gets us a negative 1/2 here. So if we just think of this as 4 over 2 plus negative 1 over 2, we should get, right, 3 over 2 down here. All right, so we've got 4 numbers on the left, so we know that that's degree 0, 1, 2, 3. So we have 4x to the 3rd minus 2x to the 2nd minus 1x plus 1. And then we have plus 3 over 2 over our x plus 1/2. Okay, now we try not to leave fractions in fractions, so here's what we're going to do. Since we took out that 2 before, let's just go ahead and multiply this by 2 over 2 to get rid of the complex fraction. Right, this has a value of 1, so we're not changing our values of anything. But when we do 2 times 3 over 2, right, it's going to cancel out those 2's. So we're going to have a 3. And then we need to distribute this 2 through here. And that's going to leave us with 2 times x would be 2x, and 2 times 1/2 would be 1. So now we're back to our original denominator there. And the rest of it can remain the same. So we have 4x to the 3rd minus 2x squared minus x plus 1 plus our remainder. Okay, so that's an important step. If you have questions about this part of it, please make sure you ask. All right, last one we have here says the volume of the box is given by 3x to the 3rd plus 8x squared minus 45x minus 50. Find the expression for the missing dimension. So I think that missing dimension is referring to the height of the box. And since we know that our volume is going to equal our length times our width times our height, we could say here that 3x to the third plus 8x squared minus 45x minus 50, right, is going to equal x plus 5 times x plus 1 times our unknown quantity there. So we need to figure out what that is. So let's just take it. We could do this in a couple steps. Let's just go ahead here and lose this factor. Right, we're going to divide this side by x plus 5, and then divide this side by x plus 5. So we could probably go ahead here and do our synthetic division with this one. So our root, if we're dividing by x plus 5, the root would be negative 5. And then our coefficients 3, 8, negative 45, and negative 50. So go ahead and go through that process. If you want to pause the video or turn me off, that's fine. Work through it and see if you get it correct. Right, and remember, if we know that x plus 5 is a factor, you should definitely get a remainder of 0. If you don't get a remainder of 0, you may have done something wrong. So this turns this side into, if we're thinking about it, right, we have 3x squared minus 7x minus 10 left over there, right, after we've divided. Right now that still equals x plus 1 times our unknown polynomial. I don't know, I put an h there. We could call it h, that's fine, but I'm calling it question mark. Okay, so then how do we get it down to get the missing one? Well, let's just divide each side by x plus 1 and see what we get. So we do the exact same kind of thing. Now we're talking about our root value is going to be negative 1. Right, and then we'll put it into our box. We got 3, negative 7, and negative 10. So 3 times negative 1 is negative 3. Add those, we get negative 10. Negative 10 times negative 1 is positive 10. And again, we shouldn't have any remainders. So 3 and negative 10 would be like saying 3x minus 10. Right, and that should be our missing value. So our original statement, right, is the equivalent of saying x plus 5 times x plus 1 times 3x minus 10. And if you took those and you multiply them all together, it would end up giving us back to this. So 3x minus 10 is our missing, is the missing dimension. All right, so that's all I got for you. Hopefully that made sense. If you have additional questions, please make sure you reach out.